Let's briefly discuss the tools that we use to analyze hurricane structure and intensity. The main tool we use is satellite imagery. And as you may know, there are several different bands of satellite imagery that we can use, only a few of which are important for hurricane. The first of which is what you see here, that is visible satellite imagery. So basically exactly what the satellite sees. So you're seeing a real representation of the clouds that are occurring throughout the atmosphere. We can also use infrared satellite imagery, in particular long-wave infrared satellite imagery. Now, infrared satellite imagery depicts the temperature of the clouds. When thunderstorm clouds get really tall, they get into much colder regions of the atmosphere. So very cold temperatures, these reds, oranges, and blacks that you see here, those are your colder cloud top temperatures. Colder cloud tops indicate more intense thunderstorms, and more intense thunderstorms can indicate that a hurricane may be strengthening. Shortwave infrared imagery is also used. It gives you a very similar picture to visible satellite imagery, but visible satellite imagery is only used during the day when there's light out, and when the sun goes down, we can switch to shortwave infrared imagery, which gives us a very similar picture to visible satellite imagery. Basically just telling us where the clouds are rather than long-wave infrared satellite imagery, which tells us the temperature of the clouds and how intense the thunderstorms are. And of course, radar data can be a very useful tool in analyzing a hurricane's structure. So satellite imagery and radar data are going to be your main tools that you'll use when out in the field to assess a hurricane structure and changes in its intensity. A tropical system needs to be vertically stacked in order for it to begin intensification. And just a refresher, vertically stacked means that the centers of low pressure, as you go up from the surface within the storm, are located on top of each other roughly. Unlike mid-latitude cyclones that produce severe weather in the United States, which are going to be tilted systems with height, hurricanes need to be vertically stacked in order for that intensification, at least robust intensification, to occur. And visible satellite's a great tool to use during the development process of a tropical system to see if the low-level and mid-level centers are co-located with one another. So here's some visible satellite imagery of Hurricane Helene as it was in its early development stages. And you can see a couple of different areas of spin here. You see these low-level clouds right here. So you can tell the height of the clouds somewhat from the visible satellite imagery. Of course, infrared imagery tells us the temperature of the clouds. That can often be a better indicator. But when we're looking for spin, visible satellite imagery is a good tool. So these more fair weather looking cumulus right here, those are our low-level clouds, indicative of the low-level center. And then these taller, puffier clouds, those are your thunderstorm clouds. Those are going to reach higher in the atmosphere, therefore they are a good proxy for your mid-level center. So if we play this visible satellite imagery here, you'll notice a couple different areas of spin. One area right in here in those low clouds, that's our low-level center. So our low-level center looks to be right in that vicinity right there. Then you see these thunderstorm clouds here, just to the southeast of that. A little difficult to tell just from the imagery here, but you can see a little bit of spin associated with those. That is our mid-level center. So you can see that those two areas, those two centers of low pressure in the low levels and the mid-levels are not co-located with each other. They're displaced from each other. That means that the system is tilted. So again, a tropical system cannot start intensifying robustly until these the low level and mid-level center are aligned with one another and vertically stacked. So that's a good thing to watch for during the development stages of a tropical cyclone. Your mid-level and low-level centers, are they co-located with one another? Once they become co-located and vertically stacked with one another, then the system can start undergoing more rapid and robust intensification.
We are currently running a massive sale on our remaining 2027 Storm Chasing Tour seats, so you can book the trip of your dreams and save hundreds or even thousands of dollars. Sale ends Wednesday, August 12th at 11:59 p.m., so don't delay and reserve your seat right now. Link in the description for more information.
Another sign of hurricane intensification is hot towers wrapping around the center of the storm. I'm going to slow this down a little bit for us here and play this back at half speed so you can see the processes here in real time. So this is ongoing Hurricane Iona out in the Pacific Ocean. So again, we're using long wave infrared imagery here. So these colors here are indicative of the temperature of the cloud tops. And these black and gray and even pink colors here, those are indicative of very tall thunderstorm clouds. These are called hot towers. And hot towers, I know it might be counterintuitive that we're saying hot towers when we're looking at very cold cloud top temperatures, but the reason they're called hot towers is because they are able to transport a lot of heat and energy upwards in the tropical system. So as you get these hot towers to start wrapping around the center, and I'll play this here again to show you how this process in action. Once these start wrapping around the center, these hot towers, this is often a sign of intensification. Usually after that, those hot towers start to wrap around the center, the eye of the hurricane will clear out, and once you have an eye, you have a full-fledged hurricane that is likely ready to intensify, sometimes rapidly. So watch these, keep your eye around the center here, watch these hot towers. You'll see that they start to rotate around the center. You see right there, they're kind of carouseling around the center. And for the moment here, we don't have any hot towers rotating, and then right there, bang, you get those hot towers wrapping around the center once again, and the eye starts to clear out right there. So let's watch this again. Hot towers start to wrap around the center. Eye doesn't clear out after this initial phase of hot towers wrapping around the center, but then eventually you see once again that those hot towers right there start to really wrap around the center. I'll back that up for us so you can see that a little bit better. So watch here as those black and gray colors really wrap hard around the center of the storm, right around there. And then you see right after that, the eye clears out that area of warmer temperatures there. That is the eye. Those hot towers wrapped around the center of the hurricane, and you have a completely enclosed eye wall and eye. So always watch out for those hot towers wrapping rapidly around the center of circulation. That's often a sign that the hurricane is rapidly intensifying, and often is a precursor to the eye clearing out, at which point you have a well-structured hurricane. Once you have a full-fledged, mature, intense hurricane, there are a few structural features you'll often see. The first of which is, of course, the eye. The eye is that area of generally clearer skies, calm weather at the center of the hurricane. It's the center of low pressure in which sinking motion promotes quiescent conditions. Surrounding the eye is the eye wall. The eye wall is a band of very intense thunderstorms surrounding the eye. These thunderstorms are the most intense within the hurricane, and you'll see generally the most intense winds within the hurricane in the eye wall. Then you have the outer bands, which emanate out from the center. These are where still intense thunderstorms are going to be located in most cases, and these are where your tornadic supercells are going to be located. Tornadic activity can occur in the outer bands of hurricanes, even though the overall winds are not going to be as strong as the thunderstorms within the eye wall. And then you see all of this high, wispy cloud cover extending outward from the hurricane. This is cirrus outflow. Now, this is not outflow in the traditional severe weather sense where winds rush out of a thunderstorm, spread out as they hit the ground. This is cirrus outflow of a hurricane. It's basically just cirrus clouds, high-level clouds that are just extending outward from the hurricane in all directions, and the presence of ample cirrus outflow usually indicates a fairly intense hurricane. Let me show you an example in motion here. And you'll notice in this example that we have all these cirrus clouds emanating outward from the hurricane in all directions, indicative of a very strong hurricane. So that is what the cirrus outflow is. And if you see a lot of cirrus outflow, it's usually a good sign that the hurricane is intensifying or is already quite intense. Now, not every hurricane is as perfect as this one with all of the features very well defined. Sometimes the eye is clouded over, sometimes the cirrus outflow is restricted, but most of the time a hurricane, a well-formed, intense hurricane is going to have most, if not all of these features: an eye, the eye wall, the outer bands, and the cirrus outflow. Now, in situations in which the eye is covered by clouds or the overall storm is seemingly disorganized based on satellite imagery, we can use microwave imagery to give us a better look at the structure of the hurricane and to tell whether or not the eye wall is actually closed. The hurricanes cannot really rapidly intensify or robustly intensify unless their eye wall is closed and you have a closed eye. And microwave imagery is really good for telling us whether or not that's the case, especially if the storm is disorganized or the eye is covered by clouds. So microwave imagery, which you can find at the University of Wisconsin website or the website called Cyclonic WX, I'm going to put a cheat sheet here with all of the resources I use when chasing and forecasting hurricanes in a document in the attachments tab below each of the videos in this series. So be sure to check that out if you're looking for where to find these products. But microwave imagery comes in two different flavors, if you will. This first one is the 89 gigahertz microwave imagery. And this is quite high resolution and can give us a really good look at the structure of the hurricane. So the reds and blacks basically are your colder temperatures. So these measure what's called brightness temperature. Brightness temperature is just the intensity of electromagnetic radiation emanating from a source. And so just in a similar vein to how infrared satellite imagery can tell us the temperature of the cloud tops, microwave imagery can penetrate through the high-level clouds that may be obscuring hurricane features and give us the brightness temperature, the intensity of electromagnetic radiation radiating off of, for example, deep convection, deep thunderstorm clouds. And so the reds and blacks here are your higher brightness temperatures, and those indicate deep convection. And you see here, we have a nice closed ring of reds there, focused around that little eye right there. So that's telling us that we have a closed ring of very intense convection wrapping around an eye that is clearing out. So this is the 89 gigahertz band. We can also use the 34 or 37 gigahertz band as well. This is not quite as high resolution as the 89 gigahertz band. The difference here is that this is a little bit better at determining a true low-level center and showing you true low-level cloud cover. The 89 gigahertz band sometimes can't resolve the low-level circulation, and so this may be more of a mid-level center that you're seeing here. But the 37 gigahertz band can tell us a little bit better the low-level structure. Does the same thing, tells us the structure of the hurricane. The pinks here are your deep convection. This is indicative of very intense scattering off of ice crystals, which ice crystals are going to be found at the top of very intense deep convection. So the pinks here are going to be where you're going to see deep thunderstorms, deep convection. And you see here that these pinks are wrapping around this center right here, so we could place the low-level center kind of right in there, and that would be a better way, slightly better way in some cases to identify the low-level center versus the 89 gigahertz band. But microwave imagery is very, very important, especially in the development phase of a hurricane when it is strengthening, but we can't really see the overall features. The satellite presentation may be a little bit on the disorganized side. The microwave imagery is going to give us a very good look at where your centers are going to be located. The mid-level center often going to be better at the 89 gigahertz band here, and then the 37 gigahertz band better for your low-level center and the overall low-level structure. You can also see kind of the banding features here with this hurricane on the microwave imagery, and so these are really good ways, good tools to use to identify certain structural features, especially the low-level and mid-level centers. So again, as far as structural changes go, we want to see a closed band of very cold brightness temperatures here surrounding the center. That means you have a closed band of deep convection around the center, and at that point, that tells you that the eye wall is closed around the eye. And again, hurricanes can't really start intensifying until that eye wall is closed and you have the eye that's completely closed off by deep convection. So in this case, you can see that that is the case in spades here. Very well-defined band of cold temperatures, deep convection surrounding that small eye right there. And same thing you can see on the 37 gigahertz imagery, that those pinks there indicative of deep convection wrapping around that center, which would be right in there. And that tells you that the convection is closed off around the eye, and therefore the hurricane is likely ready to intensify or is in an intensification phase. This was the satellite imagery, infrared satellite imagery at that same time. You can see that we had a nice eye developing, nice closed ring of very cold temperatures aloft. And so this was a hurricane that was undergoing fairly robust intensification. Another sign that a hurricane is intensifying is if temperatures within the eye are warming. So we're going to switch back to our infrared satellite imagery for this. And so we just want to see with time that the temperatures that the infrared satellite imagery is depicting within the eye are warming with time. That indicates an intensifying hurricane. So in this example, this is Hurricane Milton from 2024. You pretty clearly can see the eye right there. It's not all that well defined. We have fairly cool temperatures within the eye, about minus 60 degrees Celsius or so. Here's your scale at the top left. And we have increasing temperatures as you go toward the left on this scale. So those greens, blues, and those whites and grays, those are your colder temperatures. So watch what happens here with the eye with time. So you see that eye starts to become a little bit more well-defined, a little bit more yellow in the eye, and then we start to get some greens and blues indicating warmer temperatures. And then by the end of the loop, that eye is very, very well-defined, and we start to see even warmer temperatures, within the eye. We start to see some of those grays, indicating temperatures near about 0 degrees Celsius within the eye, showing that the eye has warmed quite a bit since that start of the loop, surrounded by those very cold cloud tops of intense thunderstorms. So that is a classic sign that a hurricane is intensifying when you have your eye that is becoming, number one, more well-defined, and number two, temperatures are warming inside the eye. That indicates that sinking motion within the eye is becoming very, very efficient, and all the processes that create the eye, they'll save the science behind the eye, the true deep science behind the eye for another day. But it just shows that the eye is becoming more well-defined and tells you that your hurricane is strengthening. Changes in the size of the eye can also indicate changes in the intensity of the hurricane. Once again, this is Hurricane Milton. We're looking at a combination of shortwave infrared at night and visible satellite imagery during the day. And you'll see here that the eye starts to clear out. It's a fairly large eye. You see right there, very well-defined eye. It is quite large. And then watch what happens as we go toward the following day. The eye maintains its fairly large size, and then it constricts quite a bit toward more of a pinhole eye. You see now the eye is constricted to a very small size. You can see those kind of rugged clouds right outside the eye. Those are indicative of very intense thunderstorms surrounding the eye. This is when it was reaching Category 5 status there in the open waters of the Gulf. But a very small pinhole eye, that indicates a very strong storm. And when you have this symmetrical cloud pattern around it, strong thunderstorms surrounding the eye, with a very tiny eye like that, what we call a pinhole eye, that's indicative of a very strong storm. Storms with larger eyes, really large eyes, don't tend to be quite as strong as these ones with pinhole eyes. Pinhole eyes indicate usually very intense hurricanes. So not to say that large eyes can't be found in very strong hurricanes, but usually when you see that eye size constrict a little bit with the favorable cloud patterns around it, indicative of a mature hurricane meeting its ceiling, then you know you have a pretty intense hurricane. All right, let's talk about the eye wall for a little bit. Again, the eye wall is that ring of very strong thunderstorms surrounding the eye, and the strongest winds within the hurricane are usually found within the eye wall. So if you're chasing a hurricane, the eye wall is what you want to target if you want the most intense experience. Now the question is, what part of the eye wall is best to target? That depends on the storm's motion. So let's say, for example, that this hurricane was moving due north. We can split the hurricane up into 4 quadrants. The front right quadrant is going to house the most intense winds, and that has to do with how the storm motion is factored into the overall net wind, if you will, on each side of the hurricane. So let's say, for example, that we have a storm motion. The hurricane is moving at, let's say, 20 knots out of the south toward the north. And let's say we have winds within the eye wall here on the northeast side at, let's say they're going to be out of the south at, let's say, 100 knots. The way we calculate the net wind is that you add your 100 knots out of the south to your 20 knots in the same direction out of the south to get a net wind of 120 knots. So that right side of the hurricane is going to possess a pretty strong wind of 120 knots. Now let's say we have the same 100-knot wind on the west side of the hurricane, the left side of the hurricane. Well, now our storm motion is opposing that 100-knot wind. So instead of having a 120-knot wind, that 20-knot storm motion is going to get factored in negatively toward the 100-knot wind. So you have a net wind of 80 knots on the west side of the hurricane. So you can see how that right side of the hurricane, given a storm motion from south to north, is going to have the strongest winds. So that northeast eye wall is going to have the strongest winds. The front right quadrant relative to the storm's motion is going to have the strongest winds. Now let's say that we have a storm motion out of the east, so a due west storm motion. Now that front right quadrant is going to be on the northwest side of the hurricane. So it all depends on the storm's motion, but the bottom line is that the front right quadrant of the hurricane relative to the storm's motion is going to have the strongest winds. So always try to target, if you're looking for the most intense experience, the front right quadrant of the hurricane. Most of the time here in the Gulf, you're going to have more of a south to north motion, so that's going to be kind of that northeast side. But if you have a west moving hurricane, it's going to be that front right quadrant on the northwest side. So always keep that in mind, that it is relative to storm motion, but that front right quadrant is going to be your best bet for the most intense winds. One of the most common structural changes of the eyewall that you'll see in pretty much every intense hurricane is an eyewall replacement cycle. Now, scientists don't really know what induces eyewall replacement cycles in hurricanes, but pretty much every single intense hurricane goes through at least one eyewall replacement cycle during its life. So what an eyewall replacement cycle is, let's say we have a typical hurricane here with a single eyewall. You see right here the single band of very intense convection surrounding the eye, which is right there. But eventually, at some point during the hurricane's life cycle, we get a secondary eyewall to develop and surround the inner eyewall. So you have a dual eyewall structure. You can see right here, it's very clear. We have our inner eyewall, this band of strong radar returns there. That's our inner eyewall surrounding the eye. And then we have a very clear secondary band of intense radar returns, intense convection there, surrounding the eye, the inner eyewall, which is called the outer eyewall. So we have an inner eyewall and an outer eyewall, concentric eyewalls. And then eventually the inner eyewall erodes away and gives way to the outer eyewall. And then you're left with, once again, a much larger single eyewall. So you see here that inner eyewall has eroded away. We now have, once again, just one band of very intense reflectivity, indicating deep, intense convection surrounding the eye, which has now become much larger. You see a much wider eye after that eyewall replacement cycle has completed. So that is what an eyewall replacement cycle is. Radar is often a very good tool to identify eyewall replacement cycles, and so is microwave imagery. So this is from Hurricane Irma in 2017. As the hurricane moves west, we get that concentric eyewall structure to develop. Here's a very good example of it. As we get right about here, you see that very well-defined ring of the inner eyewall, and then a very clear closed outer eyewall, indicating concentric eyewalls and an eyewall replacement cycle. Eventually, the inner eyewall erodes away, and you're left with just the outer eyewall right about there. You see now that inner eyewall, that inner ring has eroded away, and now we just have that inner eyewall, or that outer eyewall that's left. And at that point, the eyewall replacement cycle is complete. You'll also often see changes in the satellite presentation of the storm. This is that same storm, Hurricane Ian from 2022. So using infrared satellite, we can see a very clear eye with that eyewall surrounding it. And then eventually, once the eyewall replacement cycle starts to occur, we get a pretty drastic change in the structure of the eye. The eye kind of clouds over. We lose the clarity in that eye. And then eventually, once the eyewall replacement cycle completes, we start to see that eye clear out again, become a little bit more symmetric. And that's a sign that the eyewall replacement cycle is long gone and intensification is underway once again. Eyewall replacement cycles are pretty reliable indicators of a downward trend in the intensity of a hurricane. The eyewall replacement cycle often leads to an increase in central pressure and a decrease in the maximum winds within the eyewall. So during an eyewall replacement cycle, the hurricane will often lose a little bit of its intensity, but often after an eyewall replacement cycle is complete, assuming the environmental conditions are there to support further intensification, the eye will often constrict a little bit once again, and you'll get back on the intensification trend here. You see that eye has constricted just a little bit, and we have a nice symmetric structure once again with just that single very intense eyewall wrapping around the center of low pressure. And so now we have returned to the intensification trend. So eyewall replacement cycles, again, we don't really know when they're going to occur in the hurricane's life cycle, but they can have significant impact on the intensity of the hurricane. Again, a downward trend in the intensity of a hurricane is likely during an eyewall replacement cycle, but oftentimes in favorable environments, the hurricane will once again continue to intensify. Once the eyewall replacement cycle is complete, you'll see the eye constrict again and clear out a little bit, and the hurricane will resume its intensification. And one more sign that a hurricane is intensifying is lots of lightning in the eyewall. If you see lots of lightning in those thunderstorms within the eyewall, then you are likely looking at a very intense hurricane.
Don't learn storm chasing alone. Go where chasers are already talking. Discord community link in description.
So the theme in the structure of most intense hurricanes is symmetry. You'll see a very symmetric storm. If you were to split these intense hurricanes in half, you'd see a very almost circular type shape, buzzsaw type shape is the word we often use for these really intense hurricanes that are just very symmetric in nature. And this indicates that there is very low vertical wind shear in the ambient environment surrounding the storm. Once you start to see asymmetries in the storm, really significant asymmetries, that might mean that wind shear is affecting your hurricane. This is Hurricane Milton from 2024. Notice how as it's moving across the Gulf north of the Yucatan Peninsula, it has a very symmetric look. It's a classic buzzsaw type hurricane. There's your eye right there. Very circular shape around that eye in terms of the thunderstorms surrounding the eye. And then you have your nice cirrus outflow on all sides of that hurricane, those high clouds spreading outward away from the center. Just a very symmetric hurricane. That persists overnight as it travels toward Florida, but then watch what happens as we get toward the next day. We start to see a degradation in the structure and drastic asymmetry in the structure of the hurricane. So our center is kind of right in here, and most of our thunderstorm activity, as you can see, is on the north and northeast side of the center. This southwest side, and pretty much all of the west side of the hurricane, west of the center, is really exposed. Not really any thunderstorm activity on that west and southwest side of the center. Well, that's because the hurricane was feeling a lot of wind shear out of the southwest and west at this point, pushing all that thunderstorm activity on the north and northeast side of the center. And that is a classic sign that your storm is getting sheared. And of course, wind shear is a hurricane killer. Hurricanes need a lack of vertical wind shear in the ambient environment to intensify because they need to be vertically stacked. So again, very symmetric hurricane, very intense hurricane, Category 5 status. And then it starts to feel the impacts of that shear, and all those storms were pushed toward the northeast side of the center because of that westerly and southwesterly wind shear. Here's another example from Hurricane Ian in 2022. As it was developing, notice the swirl in the low levels right here with all the thunderstorm activity well to the west of that swirl, indicating a lot of easterly wind shear imparting its influence on the storm. I'll go back and show you, play the loop here in full. Notice how the swirls right there, all the thunderstorms off to the west, and then eventually we saw that shear weaken and the thunderstorm started to become co-located with the center. But initially, strong shear was hindering the development of Ian and displacing those thunderstorms to the west. A useful tool for diagnosing the degree of vertical wind shear around an ongoing hurricane is the CIMSS tropical cyclone page from the University of Wisconsin-Madison. You can click on any ongoing storm here on the map. We'll take a look at ongoing tropical storm Iona in the Pacific, and you can get a satellite-derived estimate of deep layer wind shear around the storm. Here is the current location of tropical storm Iona, and you can see in the contours here about 15 to 20 knots of wind shear around the storm, which is quite high. The greater the vertical wind shear is around the storm, the more likely the storm is to have its structure disrupted, and the more likely intensification will be prevented until that wind shear weakens.
Remember to check out those links in the description below, and then watch another video.